Hello, today I'm going to teach you guys how to design, build and configure a network with multiple subnets using Cisco Packet Tracer. So we have to design a network which connects two departments, sales and support. Each department should contain multiple end devices such as a PC or a printer, etc. We need to use the appropriate number of switches and routers, and we've been given the IP address 192.168.30.0, and we need to ensure that all the interfaces are configured correctly. Also, all devices in the network should be connected using the appropriate cables, and finally we're going to test this communication between each department using ICMP, which is a network protocol used for sending error messages and operational information about network conditions such as packet delivery failures. So let's quickly build the network based on the scenario. So first we're going to need a router. For this example we'll use the Cisco 2911 integrated service router. These routers are designed for small to medium sized businesses, so perfect for this scenario. Then we can add our switches, which will be used to manage each of our subnets. So for this we'll use the Cisco Catalyst 2960-24TT, which is also designed for small to medium sized business. 2960 is the series number of the switch, 24 represents 24 ports on the switch, and the TT indicates twisted pair or twisted tuned. So once we've added all the devices, we can connect them using the correct cables. In this case we'll be using the most common connectors and cables in use, which would be an RJ45 connector with most likely a Cat6 Ethernet cable, which is typically unshielded twisted pair. So let's connect them up. So we have the network address. This is the public address of our router, and it's given to us by our ISP or internet service provider. The interfaces and devices within this network, however, will be assigned private IPs because there's a shortage of version 4 IP addresses. This is because version 4 IP addresses consist of a 32-bit number. So with that you can only have a maximum of 4.3 billion unique addresses. So because of this, devices within your LAN will utilize private IP addresses. These addresses are only used within the LAN. In order for these private IPs to communicate outside of the LAN, NAT is used. So NAT, or network address translation, is a technique used by routers which converts the private IP address of the sender to the public IP address of the router while maintaining a mapping table so it can be routed to the correct device on return. This allows us to have a lot more than 4.3 billion devices connected to the internet. Before we can assign static IPs to our network devices, we must first calculate our subnet mask, and when designing a network it is important to understand subnetting and subnet masks, and it is really simple. So first you need to understand that an IP address consists of two parts, a network address and a host address. All the subnet mask does is tells us which part of the IP address is the network address and which part is the host address. So our router's public IP address is 192.168.30.0, and the default subnet mask for this is 255.255.255.0. So to understand subnet masks better, it's easier to convert them to binary. So the default subnet mask would look like this. If the number is a binary 1, then it indicates that it's the network address portion, and if it's a 0, it's indicating a host portion of the IP address. If we left the subnet as it is, we would have one network with 256 addresses ranging from 0 to 255. The first is reserved for a network address, so that cannot be used, which would be 0, and the last is always the broadcast address, which would be 255, which leaves us with a range of 254 IP addresses for interfaces and devices within our subnet. So all subnetting is, guys, is the process of changing the default network mask by borrowing some of the bits from the host portion and using them to create subnets. So in this scenario we need two subnets, therefore we must change the subnet mask by borrowing some bits. So to help you guys understand, I'm going to quickly show you how to calculate your subnet masks based on your scenario. So in subnetting, if you borrow one binary bit, so this would be our new subnet mask, you divide the network in half. So instead of having one network with 256 addresses, which is the case for the default subnet mask, we would instead have two subnets, each with 128 addresses. First with 0 to 127, and the second with 128 to 255. If you borrow a second bit, we would again be dividing the network, and we will now have four networks, each with 64 addresses each. If we borrow a third bit, we would again be dividing the network, and we would now have 8 subnets with 32 addresses each. Each time we borrow another bit from the host portion, we divide the network as such. So if we look at our scenario, we need two subnets, therefore we need to borrow one bit, which leaves us with a subnet mask as 255.255.255.128, or in binary it's here. You can see the borrowed bit at the last octet. So like I stated previously, the first IP in the subnet is reserved for the network address, so our network address would be 192.168.30.0, and the last address is also reserved for the broadcast address, which means our broadcast address would be 192.168.30.127. So every address in between the network address and the broadcast address would be our valid range of IP addresses. So now we'll do the same for the second subnet. So our subnet mask is the same. The network address, or the first address in this subnet, is 192.168.30.128, and the broadcast address, or last available address in the subnet, is 192.168.30.255. Therefore 192.168.30.129 to 192.168.30.254 would be our valid range of IP addresses we can assign to the network and end devices. Alright, so now back in Cisco Packet Tracer, and we're just going to configure the router and the end devices to enable connectivity between both subnets. So as you can see, it's down currently because neither of the interfaces are configured. And don't be fooled by the green here showing it's okay. It's not. It's just because the PCs can communicate with the switch without IPs using the Ethernet protocol, but they still won't be able to access the internet or anything. So first thing we're going to do is go to the router, and we're going to go to the command line interface. We've got the privilege mode using N, or short for enable. I'm going to configure two terminals at once to turn them both on. So we're going to go interface, and then we're going to do range function because multiple. We're going to choose both interfaces that we want to configure, which is 0 and 1, the first two for each subnet, and then we're going to do no shutdown, which turns them on. So you can see both the state has been turned to up on 0 and 1. That's good. Then we're going to go to each individual interface now, and we're going to configure them individually. So there, and then we're going to give it an IP address of 192. This is for the first interface, 168.30.1, the first available address after. Oh, sorry, I need to also do the subnet mask, which is 128, because we're borrowing 1 bit for 2 subnets, and then we can exit out of that. That's for the first subnet. For the second subnet, we'll go to the next interface on the router, and we can give this an IP address of 192.168.30.129, which is the first available address after the network address for that subnet, and then the same subnet mask. So we can exit out of this. We can do right, save the configuration, and we can do show start to view the start configuration just to check that it's double okay. So yep, we can see there's no shutdown, they're both active, and the IP address and the subnet masks have been configured and they look right. Yeah, so we can exit out of this, and we can go to the end devices. So we'll do this one, and we will do IP configuration, and we'll give it an IP address. So second, and then subnet mask is the same. The defaults, this is the interface of the router, which is the subnet is connected to, so we just configured this, so it's the exact same. Perfect. And then same for this one, we give it a new IP address, 192.168.30.3, and subnet mask, and then defaults is same again. Perfect. Now we're going to do the support subnet, so we'll just configure these end devices. 192.168.30.130 is the next available address, and then the same subnet mask, and the default gateway is different now for this subnet, so it's 30.129, which is what we configured on the router for this interface. And then we'll do the next PC in this subnet, 192.168.30.131, same subnet mask. Default gateway is the same, 129, and boom. So now we should have connectivity, so we're just going to use IMCP or a ping to check. So we can open command prompt, and we can just do IP config just to check the IP address first. So you can see for this PC in the sales department, the IP address is 192.168.30.2, and we're going to ping the one in the other subnet, which is 192.168.30.130. Due to the routing tables, the first ping should fail, however all the others should be fine. So you see you can request timeout for the first ping packet, but the rest are coming through, and we can check that again. Yep, and there we go, check that again. Yep, so you see we have connectivity, and that's all set up. So that's how you connect multiple subnets together in Cisco Packet Tracer, configure the networks, and also assign subnettings and find out the network ID and the broadcast address for various subnets. I hope you enjoyed.